Hey, hello there, and welcome back to another Advent of Code video. So today is the day 8, but I'm not going to do the 8th puzzle in this video or right now. I want to revisit something about the yesterday's puzzle. So let's open the code. So yesterday's puzzle involved this camel cards game, and we needed to basically have different hands of cards, and we need to sort them by two different criteria, one for part 1 and another one slightly different for part 2. They introduced the jokers there. And I was more or less pleased with this solution, but yesterday night I came across this post on the Rust subreddit that talked about how the derive Ord macro was so powerful, and that they could implement all of this with just deriving Ord. And I realized that, oh man, I want to try this. So this is what I want to do in this video. By the way, yesterday night I gave this a little try, and I know that this is going to work, or I'm pretty sure it will. But yeah, I want to give it an actual try now and going all the way through. But I'm just mentioning that to make it clear this is not a 100% improvised thing as my usual videos. So where should we start? By the way, this I'm just looking at this, and this is another trick that I saw yesterday on that Reddit post, which is using zip and a range starting from 1 and without an end to enumerate things, but starting using 1 based index instead of 0 based index. So this is basically the same as enumerate, but with enumerate you have to add 1 here, because these indices for the cards are one based on Advent of Code. And actually this is going to complain because the bit here, well the bit number is a 64-bit. Oh, this is also the other way around. Enumerate gives us first the index and then the element. But even with this, it's gonna complain because the I here is of type usize, and these are not the same thing, so we have to do some type conversion. So this is I find this much more noisy, and I'm still missing something. What is this? What's going on? Oh, I should convert it to the correct type, so U64. And now it will work the same, but I don't know, I find the zip trick, you could say, to be much more readable. And this is actually doing two things at once. It's letting us index starting at 1, which sometimes is necessary, but it's also more flexible in terms of the types of the numbers. So we are not specifying which number type this one is. It's just being inferred from this operation. Since it's being multiplied by a 64-bit number, Rust can infer that this one is also a 64-bit number. So that's also very useful. I think we don't have to do numeric conversions here. So yeah, all in all, I think this is a very little trick, but I think pretty useful, and I hope to remember to use it in the future. Anyway, close parentheses. Let's try to do this ordering thing. So in the actual solution, that we did yesterday, we implemented a custom ordering for these hands. So the idea would be, instead of having a custom order, let Rust derive everything, all the ordering we need, which we actually kind of did yesterday a little bit. We are using this enum for the different hand types. So this is 4 of a kind, full house, and all of that. They are ordered by how valuable they are, or how powerful they are. And well, we did this for this, and actually when we are comparing things, we are first comparing the hand type for a given hand, comparing it to the other hand type And then if those two things are equal, we are comparing the cards and mapping them with this card value thingy. Cards are just characters, and then we basically look, this is kind of a lookup table or lookup array. We search for their index here and know how they rank between each other, like which are how they compare between each other. So but these, we are delegating basically this comparison. We are having an array of five characters, mapping this to 5 numbers, and then comparing those two arrays. So we are also delegating the comparison of arrays, which Rust implements the way that we want, like doing a lexicographical or lexicographic comparison, like 1 by 1, and that's exactly what we need. So this should give us a hint of, instead of having the cards being just characters, why don't we have an actual card type that knows how to compare itself, and this would become much easier. So I think that's what we want to, and if we have that, we would have an array of cards here, and if we also included here the hand type, for instance, and this is a hand type, then we can derive Ord on this type, and it will do the right thing, that it will first compare the hand type, because this are also comparable, and then it will compare the cards themselves, and everything will be generated for us. So that's kind of the idea. And maybe let's go back to this. And also about this code that we are doing here, we have this sort of comparison, and then we have another custom comparison, which is compare with jokers, where we sort of reinterpret the cards that we have with the J's as being jokers instead of jacks. And in both of these cases, we are doing this idea of, okay, first compare the hand types, and then if they are equal, we are using this chaining operation here on the ordering type. Then we compare with this function that compares the cards of each hand. But this is the same as writing, and I think this might be clearer. We can have a tuple, or a 2-element array that we want to compare, where we put the two things that we want to compare. Okay, compare the hand type and my hand type and my card values with the other hand type. So another tuple here, and another card values. And this will also need, this needs a reference here, but then you can kill all this code. And this is basically the same that we were doing before. If we run check all, they should still pass, yes. Okay. So yeah, this is also something that I think I should remember in the future. Many things in Rust already implement ordering, so there is no point in doing this chain comparison thing if you can just say, okay, compare my hand type and my card values with the other hand type and card values, and the logic of first comparing the first and then comparing the second is already implemented for tuples. Okay. So, well, this is basically the same that we had before. We can leave it there. So what I want to do then is introduce a card type that knows how to compare itself. So let's just bite the bullet and replace this chars here with a card type, and let's put it after the hand type. So this is also going to be an enum. And let's order these things by their value. So actually, the joker is the least valuable one. And this is also another benefit of having an actual type for cards. We can differentiate here between jokers and jacks, and model the things a bit more nicely, I think. So it comes the joker, then it comes the all the numbers, so it will be 2, 3, and so on. I don't want to type the number, so I'm just going to say the number types. So this will be from 2 to 10. Then we're gonna have the jacks, not jack, the queen, and the king. Okay, and I think that's it for the cards. But now that the cards are this thing, and well, by the way, now that they are like this, we can derive everything that we want. So derive Ord. Actually, I think all of this: equality and orderability, and well, hands needs to be copy. So I also want clone and copy. Okay, lots of things being derived here. Now that we have this, we have a bunch of errors because we are treating these things as cards. But the first error is the easiest to fix, I think, because this is complaining about this card value function that expects a character. But the cards with this already implements the right ordering, right? Enums are ordered in the order that you type them. So this is less than this, and less than this, and less than this, and this one, which includes a number, also will take the number that it has into account. So that's awesome. We don't need to implement anything custom for the ordering of this. These are already sortable. So we can just say, okay, compare the cards with the other cards. And this becomes like a one-liner. Okay, let's follow along with this idea. Then we're going to have to fix, well, a bunch of things. Hand type. Actually, this should work the same as before. Why is it not working? Okay. Yeah, since we are getting the counts of all the cards, this counts returns a hash map. So it needs the cards to be hashable. So one thing more to derive, sure. And hand types with jokers and compare with jokers. You know what? I'm going to leave the things about part 2 for later. So let's comment all of part 2 here. Yeah, all of this. And let's just print the answer for part 1. What else is missing? Yeah, the parsing. So now we have characters, and we would need to actually have cards instead of characters. So we are going to map each character to, let's say, card parse character, and this will be can fail, so we are gonna need to get error propagation here. So please generate this function. Look at this, it generated it with almost everything that I want, except that I want this to be an AOC result. And that's it, right? This now compiles, sure. Now, how do we do the parsing? Well, it's going to be a matter of just matching the character. So when parsing, we are going to interpret the J's as jacks, not as jokers, to have like the part 1 solution. So if the thing is okay, let's go maybe from most valuable to least valuable. I don't know why. Card, king. You know why? It's always with these enums, I'm always tempted to just say, hey, use the card enum names to just type them out, you know, more like I find this quite more clean. What's the problem here? You need to be an OK thing because we are returning a result. Sure, we can wrap this with OK. And then we can say, okay, queens, Qs are going to be queen, J's are going to be jacks, no hacks, jacks. And then the numbers, we're going to say, okay, from 0 to, and including 9. No, actually, no, we need to go from 2, like 0 and 1. Oh, and 1 is the ace. I was forgetting about that. Ace is the most valuable one, more than kings. So from 0 to 9, it's going to be a number. Okay, maybe the name number here without the card prefix is a bit weird, but card number could be, or number card. But anyway, and we can get this character, I guess, and say digit something, 2 digits. Something like this. This is optional, so we should say okay, or I mean, no, this should not fail because we already know that these are digits from this matching, so this is safe. Oh, and I guess 2 digits returns a U32. Sure, we can make it 32-bit number. Why not? I'm not. Can we do instead of this maybe something like character minus? No, not a minus 0. Does this work? Probably not, right? Yeah, you cannot subtract characters, but we can probably say as U32 minus 0 as U32. And this I think should work, yeah. And yeah, we don't need to do like actual parsing here. We know that these are already digits, so I think this should be fine. And that's it. That is, oh, the tens, yes. Also, the input has the letter T for tens, because it turns out that poker cards go from 1 to 10. They are different than Spanish cards, which is what I'm used to. Okay, and anything else should be unreachable, so we are going to say, usually I'm more used to say, okay, unreachable, and put a nice error message here, but I think now that we want to propagate things, we want to say, okay, error, and we can use the format macro to have the nice error message. So unexpected or invalid card, and just print the character. Invalid character, let's say. Okay, and we want to propagate this error wrap, so does this work? Yes. Oh, aces. Aces were A, right? Yes, A, okay. I was missing that, so A is ace. Okay, and jokers, we are still not using them. So with that, we have the parsing done. And now these card values, which are the ordering of the cards from 2 to aces, and when considering jokers, now this is not needed anymore. This is already encoded in the enum itself. So this is the order of cards. And let's ignore the warning about joker not being used. This is also something that can be inlined. Yeah, with all of that, if we run the checks, this will fail because now part 2 is not here. But look at that, the sample, the actual output was this, the correct part 1, and well, it's not printing anything for part 2. And for the answer, for the actual input, we are also having the same number. So this is working just as it was before, but with, oh, yes, okay, we are implementing our custom ordering, but now this custom ordering is just comparing, oh, the hand type. Hand type is a method It's not something on the card. So that's the next thing to do. We'll remove this custom ordering and put the hand type here on the hand itself, so it can just be derived. Hand type is going to be of type hand type, and we will derive ord and partial ord. And why don't you want copy? Because probably the hand type is not copy. So we sort of are implementing everything for everything here, or deriving everything for every type, but that's fine. And now when we constructed the hands, we shouldn't be saying, okay, like this. Let's introduce a constructor to which we are going to pass the cards themselves, right? I think so. Okay, let's generate this function. Let's put it on the top. Interesting thing that it's generated here is like a never type, but yeah, it's going to receive the cards, and this is just going to be, well, the type of the cards, which I think it is an array of 5 elements. These things are trivially copyable, so I think it's fine to pass them by value instead of by reference. And this should return a card, so a hand, sorry, so this would be a hand with the hand type of, and we want to, it used to be a method on an instance, but now I think it can just be a like static function, or I don't know how this is called in Rust, like calculated from the cards itself. We are going to calculate the hand type for this given card. So here we called card, no, not card, this is hand type for this given cards, and then just pass in the cards for the hand. Okay, and finally the hand type is going to not access self, but everything else should be the same. It's like we are deriving the hand type from the cards itself. And look at this, we are no longer using the ordering enum. And I think that's it for part 1, right? If we run this, some error. Oh, okay, yes, we missed semicolon here. Great, this got a bit more compact. That's always nice. If we run now, okay, we still have the correct answer for part 1. And we are not using Joker. So that is it. That's the refactor that I wanted to do, or to try. I'm still going to continue and do part 2, but you can see that before we used to have, maybe we can see the diffs here, although I don't know how readable this is with a font type, font size that I use for these videos. But okay, we do have a bit more types, but this is amazing. Like this little thing replaces these 2 functions basically, because it encodes both the order for the part 1 and for the part 2, because it already has the jokers being the least powerful. Well, not the least powerful. The least powerful comparing hand to hand, but they are the most powerful when trying to determine the hand type, which is what we still need to re-implement with this model. But yeah, I think that this is a very nice change already, and this is also kind of a good lesson to learn about parsing. Like in the previous video, I mentioned the phrase of parse, don't validate, which refers, like, it's mostly used for security reasons. Like when you're parsing something, you are forced to deal with like the actual edge cases, and the input has to be valid in order to be parsed. Whereas if you need to force things by validation, people get lenient and you get the kind of thing that we had before, where we were treating cards as simple characters, but you know there could be invalid cards there, and we were just like ignoring those things and generally like not modeling things very nicely, I think. But now that we have a card type, we're just parsing the cards, and we don't need to validate anything. And actually, this encodes like better information. And you cannot, with this, you cannot have invalid hands now. That once we have parsed them, we know that the hands are valid, because it cannot contain characters that are invalid. Actually, there could be some invalid. The way that we did the numbers here, this allows any 32-bit number. So maybe this is a bad idea. We could have had like the enum names for like 2, 3, 4, and so on up to 10. But it's better than before. That's the point. Okay, now let's try to implement part 2. So for part 1, we are doing this. Have the hands here. The hands actually have the hand and the bit for this thing, for the hand. And we are sorting these tuples by the hand, which are which can be ordered. And for part 2, we used to do this, okay, compare with jokers thing. But what I think I want to do is just simply convert, because the cards that we have parsed, they don't have jokers. We can convert these cards, all the jacks that are there, treat them as jokers, and then just resort the hands. So I'm wondering if this is something that I don't know yet how to do. We have different possibilities. Like I want to do the same ordering here instead of compare with jokers. Just sort by hand. But I want to. I think we could convert the hands that we already have, or maybe we can just like parse them again. And instead of parsing J's as jacks, we just parse the J's as jokers. I think that's... Yeah, let's do that. So I usually don't parse the inputs twice, but this is something that many people do for Advent of Code. Like they have part 1 and part 2, they very separated things, and they just re-parse things again. So yeah, we can parse the things, and when parsing, we can have a boolean or something, and say J's as jokers. And you know, if this is true, we are going to parse the J's in the input as jokers. So we need to pass this here. So this is a line, and we're gonna parse line, passing the line. And for part 1, the J's are not jokers, so false. And for part 2, it's gonna be the same. Whoops. But we're gonna say, okay, now parse the jacks as the J's as jokers. Oops, I went into full screen mode. Actually, this full screen mode is, yeah, this looks nicer. I don't know why I wasn't using that. More real estate. So okay, let's now see how are we going to do this. So this has to still be passed to the card parse method, because it's card parse what knows how to parse every character. So extract into variables. This is something that Rust Analyzer could have. Like, okay, you have this problem. It's like, okay, introduce this parameter there, and you know, fix this thing for me. Okay, J's as jokers. So now when we see a J, we can ask if J's as jokers, then this is gonna be a joker, and otherwise it's gonna be a jack. Okay. Yeah. Yeah, this is cool. Sure. I wonder if having like the if condition here, if J's as jokers, and just simply say joker here, and otherwise it's gonna be a jack. It's just a little trick, but leaves everything a bit more like succinct. Yes, I think I would prefer this. Okay, so we should be parsing now, but we don't have the joker logic of like changing the hand type when you have a joker. So this I think would run. Let's run this thing. But yeah, the answer, no, we are not printing. Or we were double printing. That's confusing. So okay, we have a different, I don't remember what is the correct, what is the expected output here. 5905. So this is what we expect. We have the same as before. Not for the actual input though. Interesting. But yeah, we're still missing some logic, because this now is able to compare things, but we are choosing the same when we construct a card, basically. Where is that? When we construct a hand, sorry, we're defining the hand type with the same logic as before, so these things are not changing. But then when we disambiguate and have to compare the cards, these are going to be compared with the actual jokers now, being the lowest value. So that should be working. That's why we see we see the same answer for the sample, because it seems like the chase there didn't change the meaning, but in the actual input we don't see the same answer as in part 1. So this seems to be working. Now let's implement the joker logic. And this compare with jokers function is something that we won't need. What I think I want to change is just simply the hand type now is going to receive the cards, and here we should consider the jokers. So let's remember what we were doing with the jokers, hand type with jokers. This is the previous function where we were replacing the jokers themselves with the other card with highest count, so to increase the hand type, and then we were delegating the hand type with a changed hand, basically. So can't we sort of put this thing into here? Like we could ask, yeah, we only need once you have the cards replaced, we can do the same logic as here. So we could do something like, if the cards contain any joker, I think this expects a reference. So if it contains any joker, yeah, let's simply redefine the card. So let's say let cards be. If it contains any joker, we are going to do something special. Otherwise, just be the same cards that we received. And yeah, we're gonna say hand. It's basically gonna be this function. But instead of hand type with joker, we're going to just take the cards and return the cards with the jokers replaced. So like replace jokers for best with for strongest hand. A very explicit name, but yeah, that's exactly what we want. So if we have any jokers, then replace the jokers for the strongest hand on these cards, and otherwise just use this card. So now this logic should be the same. We should have no jokers, and here what we're going to do, I think, is pretty similar. we're gonna have the counts of the cards excluding the jokers. So this we can just say joker. Yeah, the counts of the cards excluding the joker, and then we're getting the highest count card. And if hand is all jokers, replacing with a valid label like aces. Let's say, okay, we're gonna use ace. Let's say if cards are all jokers, replace them with a valid card like aces. Yeah, this sort of makes sense. This is actually for strongest hand type, let's say, you know, to be precise. Okay, so this should still work. And then we don't need to return a hand and do all of this. We just want to have this cards. No, this, right? Close this. So yeah, we just want to have the cards mapped, and if the card is a joker, we are gonna replace it with the highest count card. Otherwise, just be the card that you, yeah, do nothing. So will this actually work? Is this all that we needed for the joker logic? Let's check all. Yeah, yes, awesome. That's it. Okay, I thought that the joker part was going to be more involved, but it's actually was very simple. Okay, like I guess the kernel of the logic was the same as before. But this is really nice, I think. So the main logic remains the same. Yeah, everything is quite nice actually. let's take a look at the diff. I wonder if the code also got smaller. It got a bit smaller also, but that's not really the main thing of having less lines, although less code is always nice. But also that I think it got much simpler too. Like before we had this compare with jokers thing, you know, custom comparison, like 2 custom comparisons, but not really working that well. Now all of that is like encoded in the types themselves, the things that we are working with. Like our hands now know how to be sorted, and also the cards can be actual jokers or jacks. Like that is also encoded in the types themselves, and I think that's quite useful. Like at least the code to me now looks much more like straightforward and direct, and we are not like doing a sort of slate of hand to implement part 2. It's like, okay, now for part 2 it's like the J's are jokers and that's it. Once you have hands with jokers, their hand type is different than when you don't have jokers. That's part of like the rules of the problem. So yeah, I like this code much better. Let's commit this and let's say derive Ord. Yes, let's say implement custom sorting on day 7 by using enums and deriving Ord. And that's it. Whoops. And okay, that's it. That's all that I wanted to try today. Before I forgot, let's actually do a little thumbnail for this video. So we're gonna use toilet as usual. And let's actually fix the day number because yesterday I forgot to do that. And let's say derive Ord for the win. Okay, How does this look? I want maybe to say for the win, let's be a bit more expressive here. Yeah, that looks nice. Let's put this to the side and show a little bit of the code. Actually, we can show all the derivations here. That's nice. So many things being derived, but I guess that's fine. It's a bit noisy if you're not used to Rust, but I think it reads quite well. We can also, why is this thing like moved to the bottom? I don't know, but let's regenerate this. We also got a bit better colors, so we can show a bit more of the code here. So yeah, that will be it for the thumbnail. So okay, that's it for day 7. I want to now continue with day 8. So if you have been, thanks for watching and see you later, I guess. Goodbye.